So I wanted to go over some data from the East Palestine, Ohio event, specifically about dioxins, and I think it's a really misunderstood compound, and just because the levels of its toxicity. So I put together a couple of slides, and it's morning sun where I'm at, so I'm going to try to keep out of the light to keep the camera from not blowing out. But here on the left-hand side, we actually have the manifest illustrating the rail cars that were involved in the incident. And then this is off the EPA's website from Norfolk Southern. The greens were the compounds. So you can see vinyl chloride, lots of tank cars of vinyl chloride. From what I could see, these are, I want to say about 15,000 gallons on the very, very, very lowest side, significantly more than that. I mean, it's, the amount of material that's lost. These benzines, man, these jumped out to me because I hear everybody talking about the vinyl chloride, not a lot about the benzene. And what I have down here is the RCRA T-clip limits. So the Resource Conservation and Recovery Act, the amount of this material that is a characteristic hazardous waste for benzene and vinyl chloride is 0.5 and 0.2 milligrams per liter in the leachate from the soil, respectively for those. And the national primary drinking water standards for benzene and vinyl chloride are 0.005 and 0.002 milligrams per liter, respectively. So, these are very, very low limits with respect to the other things that are considered characteristic toxic wastes. So things like, barium, arsenic, those types of things. There's a whole suite of compounds that RCRA requires folks to test for when you're profiling things into landfills. And benzene and vinyl chloride is, I believe, one of the lowest. So in the middle, you have the illustration of the fire of these chlorinated, the vinyl chloride, the chlorinated hydrocarbons, the chlorinated organic compounds. And we have an illustration of a dioxin to the right. So, people talk about 2378 TCDD. Well, what the hell does that mean? Under UPAC, this is a word I haven't used in many, many, many years, but we identify these organic compounds by where things are on the molecule. So we name them by the position on the benzene ring. So we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 total positions here. 10 and 5 are taken up by the oxygen. And when we say 2, 3, 7, 8, we see 2, 3, 7, and 8, the chlorine is in those positions. Well, what you have to think about here is the charge that makes on the compound, and where that's going to end up in the body. Is it going to be fat soluble? Is it going to be water soluble? So in these, they're going to be fat soluble. They seek fat, and that's where they bioaccumulate in animals and people and things like that. So the 2, 3, 7, 8 positions. So chlorine can be anywhere on that ring, and this event is likely to form dioxins, all different kinds. Some with 4 chlorines, 5 chlorines, 6 chlorines, but the ones with the when I say ones, the word that we use for these is called isomers. So these compounds that have the chlorine in the 2, the 3, the 7, and the 8 positions are the most toxic. This is an image showing the various different isomers. So, you can have tetrachlorinated dioxins, penta, hexa, hepta, and the octachlorinated dioxins. So, this is basically every location there's a chlorine. You can see this is in analytical testing. They talk about method detection limits. This is a method reporting limit. This is a little bit different because these are quantitated and detected differently than other things. So you're getting a sample specific detection limit based off of isotopically labeled homologs. So what does that means? We're adding known amounts of isotopically labeled compounds, so 13C. So we can tell the difference between those, and we see how those react in the sample. And based off of that, based off of what comes out of that, we know if it's a what kind of bias there is. So if we know that we put 100, picograms in, and we're getting out 50, we know that that sample likely has a low bias. Likewise, if we're putting in 100 and we're getting 200 out, we know that something happened in the extraction procedure that would give those results a high bias. So all of that's taken into account, and we're getting these values instead of an MDL. And then these toxicity equivalent factors, TEFs, which are used by the World Health Organization to do what's called toxicity equivalence. So like I said before, you can have, all of these things in a sample. You're not just going to have 2378 TCDD, you're going to have, all these different isomers. And, from a toxicity standpoint, they're not all the same. So you can see that the lower the toxicity equivalence factor means the less toxic it is. 2378 TCDD is the most toxic compound that we know of. So that gets a TEF of 1. The octachlorinated ones are 1, 2, 3, a couple orders of magnitude lower, 3 orders of magnitude lower than that. So, which is good because these things are everywhere. The octachlorinated dibenzo P dioxins are, they're in you, they're in me, they're in my cat that's laying at my feet. They're in every, they're in milk, they're in everything that we eat, they're in our soil. So they're everywhere at this stage. And that's one of the reasons why the EPA has dragged their feet on wanting to test for dioxins in East Palestine, is because they know that they're going to find this stuff everywhere. And they're concerned that once they start finding it, people are going to just start jumping off of bridges. So that's one of the reasons why I'm doing these sessions here is to educate, because things are spun and taken out of context. It's important to have the context with this. So we're going to find dioxins in East Palestine. We're going to find dioxins in Yosemite National Park, right? They're everywhere. But this is one way that we look at it.